Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back to NPTEL online certification course on research methodology for planning and architecture. In my last lecture towards the end, I mentioned about something on big data. Now you must have heard about this kind of information nowadays, like through your peers, maybe in the media, maybe in some research paper, that big data analysis and handling big data is something really taking the market and need of the hour, as because now with the digitization much more data are available which can be useful for our research, but we should also understand how to handle that information. The real time data that may be captured in terms of, say, pollution parameters, or it may be just intersection data. The data can be of any type depending on the purpose and need, but how to handle that big amount of data. So this kind of computational analysis, how we can perform, these are the questions. Now for the field of architecture and planning, we are also not behind. We are also using those kind of analysis. We are doing research on big data in some part. So with that, we'll be discussing some of the very basics of this handling big data. So we are at lecture number 57. Today we'll be discussing about handling big data research, and we'll discuss very basics. We'll not go into detailed description of each of them or maybe different stages, because it is not in purview of this course. I just thought that we just touch upon this in a fashion so that you can get interested and then you can search for such kind of materials available, right? So in this particular lecture, what we are going to learn, we'll try to understand what is big data, then big data and built environment research, then we'll discuss about advantages of big data in planning and architecture application. Then along with that, we'll also discuss about various challenges in handling big data, and also we'll summarize our understanding towards the end of this lecture. Now what is big data? You may get n number of definitions if you search in Google, if you search in some online platform. So here I just put one. Big data is the information asset characterized by a high volume, velocity and variety to require specific technology and analytical methods for its, say, for production and transformation into value. Now we'll try to explain it. Now definitely whenever it is a big data, it's nothing but data means information, and it essentially consists of high volume and velocity. So the data is keep on updating. It is not that once it is there and there is no upgradation. So maybe when you talk about the real time data, it is there, and there are variety of information that are coming into picture. Now how we can use specific technology and different analysis to analyze those results, to analyze those data, and then come up with certain sort of value which is giving us some sort of opportunity to make certain decision making. So that is all about the big data. Now application of big data in built environment studies, especially in architecture and planning, it is actually helping the researcher for traditional field support and also the innovation leading, because when data are available but you don't have the idea how to analyze it and take a call on that, maybe for certain sort of decision support system you need those kind of real time information, and through your modeling you can give some sort of decision at the real time. Now some of the field that actually we can use those kind of big data information. One is the behavior data acquisition and analysis, which also we discussed that how the behavioral data can make a change in overall design and planning approach. For spatial analysis, we can also do such kind of performance analysis based on certain input parameters. When you have the big data and you can do this spatial analysis, it can also help you to have a proper planning and management of the project, and also it can instigate to derive for some new methodologies with big data. Now coming to the behavior data acquisition and analysis. So many a times we do some sort of spatiotemporal interaction data like GPS log data from handheld GPS devices. So say for example you have to do some sort of mapping of a location, you have to create a base map and all. So for such kind of cases you can use those kind of GPS based data. See, another example of this is something like the mobile phone data. Now I just mention about this, you can search in Google. So there is something called Google Mobility Report. What actually it does, like now all of us possibly now we are using this smartphone and we make our location on. Sometimes we also navigate our path through the Google map and all, and it is, if you notice that it is stored, like it virtually it's stored in some locations, and you can receive the email about that last month you have visited this many places and all. So in Google Mobility Report they also capture that information and they publish that how many people or the percentage of people they are making the retail trip, or maybe there are different type of trip purposes that for which we are making our trip. So they published, okay, during COVID lockdown, okay, they published certain report which was like something like very helpful. Many researchers they have used in their paper that how the trip pattern that has changed, that how the residential trip were still high, but for visiting park, visiting public places were reduced drastically. So my point is that with those kind of mobile data and all, we can do the analysis. Even when we talk about typical origin destination survey for transportation planning, it requires time, it requires manpower, and it's a long travel diary that one has to fill to understand. But now in some cases, some of the cities where there are certain sort of collaboration with the mobile data operators and also the research institute, they can use those kind of mesh data, mobile data to predict the possible origin destination and also the real time activity mapping, that where people are going, where is the trend, and then they apply certain sort of simulation into it. Smart card data is also useful to make certain predictions. Suppose nowadays for traveling in metro, traveling in certain transit, you have smart card. Through that you just punch it, and whenever you punch it, so your record has been transferred. So you are making one trip, you are consuming certain amount of your overall wallet. So with that you can also get a clue that the boarding station and alighting station of a customer, then at any point of time you can estimate that whatever, like which are the station which are having high load and all. Even for smart data, whenever you just do this activity pattern, like something like you go for a shopping, you go for certain thing and you use your smart card, so that can also be captured very easily. GPS data from floating cars and taxi. So now whenever you book say Ola, Uber, all those kind of dial ride options, the ride sharing options, so there you also have those kind of information, right? So that can also be used. Points of interest data, like it is something like source from malls, public utilities, where based on the ticketing data, whenever you enter, so there is some sort of kind of face detection and all. So all such kind of informations are there. Now how you analyze it in a given time, what is the maximum footfall, what could be the maximum parking demand in a shopping mall, those kind of analysis can be very well performed if you have access to those information. And that is something, the application of the big data, where you can do this analysis of how, different times you have different type of pattern, and also the temporal thing, like definitely different time we are talking about, and for spatial, like place to place, that probably in the daytime this is the area where people are coming towards CBD for the work, or maybe in the weekend they're traveling to some of the recreational space in the city. Now coming to the individual attribute data, so it is something like volunteer geographic information, the VGI, is maybe different search engine data and social media post. So whenever you search something, definitely based on that search there are algorithm, you must have noticed it, like nowadays in your mobile phone or computer, if you search about some locations that you plan to visit, okay, next time whenever if you are logged into that particular system, you will get those kind of prompt that okay, now these are the possible locations that you visit, or these are the possible hotels that you can book. Some of the algorithm which helped to take care of this search engine data. And social media post is something where, like some of the tools like Twitter sentiment analysis and all, where the researcher can get access to those kind of tweet, retweet, or maybe this is some comments, some feedback, certain response given to the e-commerce website, and then you can analyze those things with different sort of API. You can get those data automatically, and then finally you can analyze those information to take a call on overall performance of that particular place, maybe the satisfaction, dissatisfaction associated with certain locations, or whatever, like whatever you want to measure, that can be done with this. So one is which is location based, GPS based, the other was like what we discussed about the search engine and the social media post. Now coming to the spatial analysis, the form and structure of dynamic flow of a regional scale, that can also be taken care of with so much of input, change in certain sort of functions and all, you can change it. Form and structure at urban scale, we can also do the urban dynamic simulation with the real time information, or maybe a lot of information if you integrate that. When you consider a urban area is a system and it actually act on the various subsystems, so maybe it is acting on the transport infrastructure, the water infrastructure, then health infrastructure, education, governance. So how you can integrate all those information? So integration in information itself is very important aspect. Physical integration is something where you connect all those amenities and then you have some sort of physical identity. But information that are flowing across different department, how we can interact, how you can get all of them to a single platform and then analyze the result. Say for example, like where is the nearby medical facility, and for that medical facility, that what kind of infrastructure that you require. So you can always go back and forth, or if you have those information, and you can make this is something like a very smart system for the city. Spatial performance of structure at regional and urban scale, that is also something that you can measure, that how things can move. So say for example, if you have that much of information about the crop pattern, or maybe that is something about the watershed management, you can do all such kind of analysis with big data and the built environment. Now for spatial analysis, like form and structure at regional scale, it is something like uncovering patterns of inter-urban trip and spatial interaction from social media and check-in data. So this is something where in this particular case study, it is a interaction map of 370 cities. The red lines indicate stronger interactions and the maximum value is 1,37,847, which is the number of trips between Shanghai and Suzhou, extracted from the check-in dataset. So this is something, you have not asked people, it is based on checked-in database, and this is something you can see that where people are going. So it is just some data sets. So it is at this particular regional scale where 370 cities and based on check-in data. So this is something like the value that, okay, it is a monthly value or annual value, depending on the amount of data you can predict it. If we talk about the form and structure at urban scale, so in this case study, exploratory calibration of spatial interaction model using GPS trajectories. It is shown here the distribution of 80% attracted trips of shopping center H over road network and predicted the trading versus observed area of shopping center H in 1. So in this case, if you see that this particular place H, so the trips are attracted. So this is at the urban scale, and also this can be done through those kind of mobile data, or it may be that shopping mall, that check-in data. When you talk about the spatial performance of structure at regional and urban scale, the inter-urban human mobility patterns and urban morphology perspective, that was the case study, which investigate how patterns of human mobility inside cities are affected by two urban morphological characteristics. One is the compactness of the space and the size. Mobile phone data were used to extract the individual's movement and trajectories. So again, the involvement is not to have a questionnaire interview, because that will take time and maybe the sample will be limited. But with this kind of mobile phone data, if you extract that individual movement trajectory, you can get this particular result in a quick time and also the large data. From the findings, it was found that individuals living in large or less compact cities generally need to travel farther on a daily basis and vice versa. So definitely whenever you have a compact city, you have all the utilities, and definitely you don't need to travel a longer distance for meeting your needs. So you can get within your city. So that is something very useful that is reflected through this data. Now coming to the planning and management, the spatial planning here in this case, the validation and summary that you can do. You can also take care of the innovation part of it, where you can create certain sort of scenario, futuristic scenario, how the land use will change, and depending on that change, what is the impact on overall network, and then optimality in the route selection and all, so that you can figure it out, and also you can perform simulation. Also it will help in plan implementation evaluation, the urban growth boundaries determination, and also the support system for planning and design. Coming to the new methodology, under spatial simulation you can go for the micro simulation model with that data, real time data, and then you try to analyze the pattern and all. It can be something, the application of the cellular automata to see the growth pattern, the different parcel, that how it is going to evolve, okay, and then finally what will be the change in the overall built pattern in the region. It may be at the urban level or it may be at the regional level. Agent based modeling is something very important for real time crowd management and all. You can apply that. And obviously the model integration, where different output of different models can act as input to integrate the model. Public participation in planning, definitely whenever we take their view on social media and then we use that information to build up. Like if they express about certain kind of park or maybe open space, like it's very well designed space and all, so for that reason we can also capture the factors which actually made them happy. Along with that, we can take certain call that okay, for such kind of design, these are very important factors and people are very satisfied with once it is provided. We can take that as a design guideline for implementing those kind of open area or public spaces in other part of the city. Now coming to the advantages of big data in planning and architecture, or in general, it will help in informed decision making because the data are real, there are very rich data. If we can analyze perfectly, we can really come up with some sort of good decision. We can also have the predictive modeling. Once you have that much of enhanced data, rich data, we can develop some sort of predictive model that how it is going to change the scenario. Resource optimization, so definitely in a conventional way we have seen that in case of that check-in data type of origin destination study, if you would have investigated in personal interview, probably it will take huge time and money because this more than a lakh data point for a particular location is very very tough. But if you apply those kind of information through the mobile data or maybe the check-in data or maybe some shopping mall data, so that can help in resource optimization. Now coming to the sustainable design, definitely whenever you have all those parameters, all those information under different heads of sustainability, you can integrate and come up with certain sort of solution. Now when you talk about the smart city and when we talk about the Internet of Things, IoT, Internet of Everything, so when you integrate all this information, automatically it will help into make the city smart. Now you must have heard about a term called digital twin. So here we actually create the hypothetical city or the virtual model of the physical model, and then you tweak and change different kind of parameters, and then you just compare that by changing certain parameters in that particular model, how it is going to affect, and if it is satisfactory leading to a certain sort of desired outcome, you can implement in the real world. It can also help in real time monitoring where the detection and other thing can be very easily done with that data. Say for pollution and all, depending on the pollution level, you can like change the route for the traffic, or sometimes even the application of this can lead to some data processing and identify the traffic rule violation. So maybe not wearing the helmet or maybe over speeding or just some issues in the intersection. So that can be very well captured and automatically can be detected, and accordingly some steps can be taken up. Even for say incident management, say for somewhere some accident has happened, through the GPS information and through that kind of information dissemination through different devices, action can be taken up. Those kind of emergency response vehicles can be sent to the spot, and then things can be solved in a better way. Even that will help to pass on the information to the other vehicles, real time of travel information, that okay, there is a congestion ahead or maybe there is some sort of accident happen, you change your route. Community engagement, as because now whenever we identify the source, like all our personal devices like mobile phone or some check-in information or maybe our some sort of purchase pattern that we have made in some e-commerce. So based on that we can identify the individual choices and the opinion, and accordingly some sort of the things can be featured. So it is as simple as that. If you have just browsed through certain electronic devices, suppose you want to purchase a headphone, you just browse through some of the headphone options and you don't do anything on that, and after that you'll receive some sort of emails, or maybe it will be prompted whenever you open that site that okay, these are the available phones and all, even you don't desire to open it. So this is something like some sort of marketing strategy where artificial intelligence and all these kind of personal choice data are combined, and then some of the outputs are coming. So that is something where you can engage the community in the analysis. Obviously, whenever you go with that big amount of data, and which is realistic data, which is like what is actually happening, the movement and all, so that can lead to some of the innovative and creative solutions. Now coming to the challenges in handling the big data, definitely the scalability of the data, because many a times there might be some errors, there might be some kind of noise in data that may not reflect the true sense. And then whenever we talk about accessing the mobile phone, even if we assume that people are having the smartphone, but many people probably they don't use it. So if you conclude something out of the people who have only having access to this mobile phone or any digital device, based on that we are making a decision, probably there is some issue. The data quality and reliability, as I already have mentioned, that how they are fitting the data. Even in e-commerce website, you must have seen somewhere people just give some sort of response or feedback towards a product, and in some cases you find that everything is good, even if you see that overall like product is not of that good quality. So how you rely on that, that is also a question. Availability of resources to handle large volume of data. So definitely for that you need again a high computational system, and also it will take time, and you need to understand how to deal with that millions of information, that how to remove the noise out of that, what kind of information you can actually extract and you can use. Next, obviously the ethical concern regarding the data privacy, and then responsible and ethical use of sensitive data. So whenever we talk about some of the countries, cities, they are using the mobile phone data from the mobile operators. So that is something in the public policy or the ethics, but you cannot simply get all those information, because there is some concern of privacy. So whether you will able to do it or not, so that kind of ethical consideration also we need to look as a researcher before you use those kind of information for our research purpose. So to summarize, yes, big data is something where you have huge amount of data which are coming continuously, high volume, high velocity, and then how you analyze is in an effective manner to convert to a meaningful findings. That is something is the task of researcher or the data analyst. Now we have discussed about the big data and built environment research, where spatiotemporal research can be done. I have also given you some sort of case examples where they have used the check-in data, or they have used the mobile data to find out the point of attraction, or you can say the zones where people are making more travel to a particular day or time. And also we have discussed about various methods by which you can perform those analysis. It has application in both planning and architecture. We have discussed several advantages of big data, where it can also be used very effectively, which can reduce the time and also the cost of getting all that information. Along with that, also we have discussed about several challenges, especially with the ethical consideration, the reliability of data, when especially we look into the information which is filled by users, like how authentic it is, how reliable it is, because based on that you can make a call. And when we talk about the digital divide, so many people they don't have access to the mobile phone, and if you are making a decision based on the mobile data and all, maybe sometimes we are having some sort of biases. So taking into those consideration, if you can handle it properly, still it is something that in days to come probably will be much more useful to take some sort of real-time decision, some meaningful decision, because huge amount of data, whenever you increase the data set, definitely it will also increase the reliability of your findings. So with that I stop here. So again, these are some further reading materials, some books or book chapters that you can go through. With that I stop here, and then our next discussion is another interesting topic, and that is on the artificial intelligence, the role of artificial intelligence in architecture and planning studies. Again, we'll discuss the very basic few points about the role of AI in architecture and planning. So with that I stop here this particular lecture. We'll be meeting soon with the new lecture. Thank you for joining. Bye bye.